right, so this episode was this is actually my third take of this episode, because originally this episode was geared towards people I wanted to include that might not have as much experience with Linux. So a lot of stuff on this channel is geared around Linux. Actually, I think all of it. And not everybody has Linux. Not everybody can dual boot. And so I wanted to put this out there that there's this thing, if you're on Windows and you'd love to follow along with some of this stuff, WSL, the Windows subsystem for Linux, is a great place to get started. So then, of course, I went through and looked at the other videos on YouTube about this, and I found some fantastic ones by David Bombal. So I'm going to actually link those down below, and I'm not going to repeat his work. Now, there are a few things that he said that really piqued my interest, and so I dug deeper in those. So this episode is all about digging a little deeper to the architecture of WSL and how it affects us with running containers. And then at the end, I'm going to share some of my favorite settings and stuff for WSL. As many of you know, because I want to focus on content creating, the Adobe Premiere suite actually helps me just not worry about editing and those things. So I do use that, which means I have to use Windows because I won't use an Apple product. So that being said, I do dual boot this one with Windows. So I have a Windows machine, so I can do some of these things and show them off, even though Windows isn't my daily driver. All right, so let's get into this.
3, 2, 1, 0.
The No Channel.
All right, so I want to make a really quick announcement. First, if you guys are liking these videos, please like and subscribe. It lets me know. It's really, if nothing else, a huge encouragement to me. I put a lot of work into making these for you guys, and yeah. The other thing that I'd like to put out there is that I have started a Discord channel. The link is below. And if you'd like to join and chat with other people that are interested in the same things, feel free to. I'll be around. I will be hanging out there. That will be a great way to contact me if you'd like. I will try to help if you have a problem or an issue, if you ask it. Discord will be a little bit easier. Please still leave YouTube comments on what you'd like to see and whatnot. I don't want to take away from that. If there's a chat that needs to be happening, that's where really the Discord channel will help out some. So feel free to do that. And thank you so much for all of your support so far. And I look forward to making some more great videos for you guys. The first thing that David Bombal said that really piqued my interest was he said something that at first I thought was a little bit incorrect in the technical details. And then the more I got into it, wasn't inherently incorrect, but I wanted to clarify what that would actually look like. So he said something along the lines that you're running an OS inside of Docker, inside of a VM, inside of an OS. And so this representation is you have Windows, and then inside of Windows, there's running this VM, which is your Linux. And then inside of that, you have Docker. And inside of Docker, you have this container that's running. And that's not really true. And it is for all intents purposes. And so as an introduction, it's fantastic. And his videos are fantastic. I highly recommend you subscribe. He would kick my pants in networking. Actually, David Bombal, if you ever watch this and want to do something with networking together, I would love to. We could do something in Kubernetes networking. I doubt he'll actually watch this video though. Anyhow, so I wanted to dig into it because honestly, I didn't know exactly how it worked. And so I dug into it, and here's the highlights. Now, as probably a lot of you know in the Windows world, Windows itself runs on top of a VM, Hyper-V. So when you install Windows, you actually install Hyper-V, and then you install the Windows kernel on top of Hyper-V. And then on top of that, you have your Windows user space. So the NT kernel, the user space, the NT kernel, and then the hypervisor. So everyone that uses Windows is actually running a VM, in theory, if you want to look at it that way. Hypervisor is the way they abstract the hardware out. So some companies like Apple don't necessarily have to have this abstraction layer because they only work on their hardware. So anyways, this is how Windows does it. I'm not saying it's right, not saying it's wrong. Quite honestly, I don't know that much about Hyper-V to tell you the internal workings. It's Hyper-V. All right. So how does then this play into WSL? So originally, WSL1 didn't have a VM at all. So what would happen is, if you're familiar with an application called Wine, there was WSL here, which was the Linux user space, which is what we consider a container, is just the containerization of the user space. And whenever it made a kernel call, it would call this translation layer. And that translation layer sat here and piped commands down to the NT kernel. So it didn't exist in a different plane. It existed in the Windows user space, and it just hit this translation layer, and that translation layer called the NT. Now, this caused them two problems. The first problem was that they had to maintain this translation layer. So if a new feature was added to the kernel and you wanted to use it, they had to add it to their translation layer. That's a lot of work. And also, they have to add every single feature, which is crazy. The second thing is, not everything is one-to-one relationship, and you can't necessarily map everything from Linux to Windows and vice versa. They take very different approaches to things. We could talk about file permissions. We could talk about namespaces and C groups. These things don't have a one-to-one relationship. There is no way to map those from Linux to the Windows kernel. It just doesn't really actually exist. Now, in Hyper-V, they've been working on this lightweight VM stuff for their enterprise customers. This lightweight VM is what is in WSL2. So WSL2 is running in a VM. It's running on Hyper-V. Now, instead of thinking of it running in the Windows user space, it's not. It's actually running in the same Hyper-V as your Windows kernel. So your Windows installation sits here, your Windows kernel on top of the hypervisor, and the Linux one is sitting right there next beside it. This is actually similar to how Docker used to work. Docker would run in hypervisor, it would run a Moby VM, which was just a Linux VM. And when you told Docker to install a new container, it would just map that to that Linux kernel that it had and create the container there in Linux. And then it did all the magic to expose that to you in Windows, just like it was running in Windows. So it's very similar to how Docker has been working for a long time. It's just now supported in the core of Windows. And you can switch Docker over to use WSL, and I highly recommend it because it gives you a lot of benefits that we'll look at in a little bit that will actually help you follow along with what we are doing on this channel. The whole point of this is that if you only have a Windows machine, you are still welcome here, and you should be able to follow along as long as you can run WSL2, which works on home editions. You don't have to have a pro edition of Windows. This should, as long as your CPU supports virtualization, be able to follow along. And that's fantastic. Now, like I said, if you need help installing this, down below, David Bombal's. He has fantastic explanation, explains it way better than I ever could. We've started to see how WSL is run. All right, now let's start understanding how some of this works, because there's a couple reasons I would not consider this a traditional VM. First, it is tightly coupled to your Windows install. So you can access the file system. It is a virtualized file system, but you can access the file system back and forth. The Windows can access the Linux file system, and the Linux file system can access the Windows file system, and very smoothly and seamlessly. And they do this by patch 9, Cloud 9, something 9 patch. No, that's Android with their UI thing. There's a 9 in it. I'm going to display it on the screen here. They use this server to translate the calls for the file system. It's actually some pretty cool technology. And that's what's doing that in the back end. So that's pretty awesome. They do some other things that allow you to expose custom operations to the kernel, so that when you run explorer.exe, it actually makes a call to Windows to run Explorer, because obviously Linux can't run that. And these are the ways that it's seamless, but also very tightly coupled. Now, another thing that I'd like to point out here is nothing runs in Docker. You might make containers using Docker. You might make containers using Cryo or Podman or whatever you want, whatever tool you want, but nothing runs in Docker. I'd like us to get away from that terminology. And I only make this distinction because your container runs due to Linux kernel support, and it runs on the Linux kernel. Docker is a utility that lets you do this cleanly, easily, and smoothly. We can actually run a container without Docker, and we can do all the steps. And we'll probably actually do that. That's on my list of things to do here. But nothing runs in Docker. Docker's not a hypervisor. Docker isn't any of that type of technology. All right? So let's not say things run in Docker. You may be using Docker to run. And if you're in Windows, you're going to kind of need to use Docker to run. I don't know that anything other than Docker is supported in WSL at this point. I couldn't find anything, and I didn't have the time to actually try to make something else work. Remember, WSL does not use the systemd in it. So anything that you're going to run, you need to use the WSL in it. And I don't really know their init system very well. So I wasn't really up to the task of delaying this 2 months as I hacked through their init system to make this work. Wasn't going to do that right away, but maybe in a future video. All right, so now the really cool thing is you can install different distributions of Linux in WSL. Did you know your distributions running in WSL are actually containers? They don't come out and say this, but I've looked over their architecture and it's quite clear. When you run Ubuntu or Leap or whatever distribution you run, you're running the user space. There is only one Linux kernel running ever. There's only one VM, and it's running their kernel. So you're already running a container. So your Ubuntu or your Leap is not a VM. It's a container in a VM. And this is where I just wanted to go through and expand on exactly what's happening in the background, because it's really cool and really fascinating. And it's actually pretty awesome how this all works together and how they made it all work together. And so, yeah, this is how they have this instantaneous boot time. It's not instantaneous. It takes about a second. But the reason is it's literally just a container. It's a container of the Linux user space running on their custom kernel. Now, their custom kernel is open source. You can see it, find it here. And they keep it pretty up to date with the latest kernel, which means you can actually run anything that the kernel supports. This is really, really cool. Okay, so I know that I've ranted on about the exact architecture of WSL. I just wanted to do this so that we could see it all drawn out like this and exactly how it looks like. So really, when you run a container in WSL2, you are running a container in a VM. That's it. The VM is a Linux VM that runs a kernel, and that runs on the hypervisor, just like your Windows install. I will now refer to my Windows install as a virtual machine because, yeah, if we're going to call this Linux a virtual machine, which it is, but all of Windows then is as well. And that's the really cool thing about virtualization. You wouldn't really realize it or even think about it, that it's down there virtualizing the hardware and whatnot. Now, the other thing that I can say is that while when you don't think about the Windows VM because it doesn't really restrict the base VM that it's running on, the hypervisor gives it all of the resources and everything. It is the machine. And so it feels very bare metal. You add another 16 gigs of memory and you get another 16 gigs of memory in your Windows VM. So it is very misconceiving. And you then would also get another 16 gigs in your Linux VM. Now, there's actually a way to limit WSL and how much it gets. And I'll show you how to configure that because that's quite honestly one of the most useful things that I know how to do with WSL. So here's a configuration file, and this just goes in your home directory. So, c/user/Merrick /.wsl config. And this is what your configuration file will look like. And this limits the memory and stuff that the hypervisor will give your WSL VM. So it is very much a VM. It has virtualized networking on the VM. I do know that they're working on making it share the same IP address. So I think that would be cool and not cool at the same time. I don't really think that they need to do that, but they think they need to. So more power to them. All right, so let's get into how you can use this to follow along with stuff that we're doing. So a lot of stuff that I do is Kubernetes or network. Network. I try to avoid networks. A lot of things that I do are Kubernetes or Linux or something on top of one of those two. So if you're wanting to follow along, you can use WSL2 and you can do everything in WSL2. You can even program for Kubernetes in WSL2. Now, while there are some reasons you might not want to build in WSL2, you can. And the greater way to build Kubernetes, the way I like, is I actually build it in a Docker container. So the best way that I've found to build it, now you can use Bazel. I don't like using Bazel. Google, yeah, I don't like Bazel. But you can use Bazel, but I actually just like building it in a container. There's a container in the repository used to build it. I use that, and it's pretty easy. So you can use WSL to do all of these things. The only thing that you can't do is systemd stuff. And really, that's not as big of a deal because with Docker's integration with the Windows subsystem for Linux, it doesn't matter. You can go into your system, install the Docker CLI, and start interacting. So if you've installed Docker for Windows, you can now use Docker in your WSL integration of choice. And I'll show you how to expose that, but it actually works very well, very easy, and allows you to run containers on that kernel that Microsoft has provided. And so now you can do anything that I've done on this channel, you can do in WSL, except for GPUs. I don't think GPUs are supported in WSL yet as of today, but I do know that's actually something they're working on. They have some stuff around that they're working on. So in the future, you'll be able to even do our GPU work in WSL. So if you're out there, you're following along here and you really like what you're seeing, but aren't ready to take the leap to dual boot, don't want to risk your computer if you find it as a risky operation, or just don't have a big enough hard drive to have 2 OSs and don't have the money to buy another one, WSL2, you can do everything that I have done. Another great way to run Kubernetes in WSL is with Kind or Minikube. You can use either one of those and build your cluster in Docker, and it works just fine. And the really great part is you can access that cluster from your Windows or from your WSL. So now let's jump into my configuration of WSL and show you how I have it configured. All right, guys. So this is my WSL config. This file gets installed here under users and then your user profile. And in your base directory, just make the .wsl config file. Now here we can see I only set 2 settings, but I find these to be the most useful. A lot of times I run random stuff in here and I don't want to accidentally forget something running here and it consume a lot of resources on my PC. So the interesting thing here is that it won't show up in processes because it's in its own VM. So Windows doesn't actually know about those processes. And so if you're like trying to figure out what and why, it won't show up here. So it's nice to have a limit on there. The other thing that I do, so this is my config. All right. So, and over here, I have a WSL running. You can see that I have Zhush running because it's a fully compliant kernel. And yeah, we can go over here. We can see that it's a Ubuntu. Let's make this full screen. We can see that it's a Ubuntu install. Let's run. So we can see that we're on the Linux kernel, 4.19. So we're not on the latest 5.0. I will be excited when they release that. And then we could do something like cat. Let's see, OS release, and you can look here and see what OS you're running. So we can see. Now, again, remember that this is just the Ubuntu user space. That's what allows us to do something like the Leap user space. And here I'm on, Etsy OS release, and we'll see that here we're on the Leap user space. So these are really just containers. They're Microsoft's own containers. I can't tell you that they're using names. I can't tell you that they implement it the exact same way, but I don't actually have a reason to believe they don't. I'm actually going to be emailing the OpenSUSE Leap people. I'm going to see if I can't help out there some. So I know a lot of the SUSE people, and I'm going to see if I can't help out with there and let you know my findings, because it is just packaging the user space. And I want to know if they do anything interesting, anything special, and maybe I can get one of the people that package that on a call and we'll have a chat. Okay, let's move on. So we've seen that. Now, the next thing, let's bring up the Docker settings. Okay, takes a little while to load. Here are our Docker settings. All right. Now, what you're going to want to do is use the WSL with instead of the legacy Hyper-V. Now, if you're on a home edition of Windows, you're going to have to use this anyways, or else it just wouldn't work. When you've done this, you actually can come over here and go to your WSL integration, and this will enable the integration with additional distros. Now, you can enable it with your default one. So if you've only installed one distribution,
and you enable it on your default one, that distribution will be the one and it will be automatically enabled on it for you. But if you have multiple, you can enable it or disable it on multiple. And now, because we have enabled it on both our Ubuntu and our Leap 15.1, we can go ahead and use Docker here. And as you can see, we're not running anything, but this is Docker, and it's running on the same kernel that this Ubuntu user space is running. Because remember, when you run a container, all you're doing is running the Linux user space on a Linux kernel. That's it. That's all it's ever been. And that's literally what Microsoft is leveraging to bring you WSL. So that's really cool. And so this is why I say now you can follow along with whatever you want on my channel in WSL. And I might even do some in WSL just to prove that in the future. So we have our Go install. So we can, go. We don't have Go. Oh, no. Check this out. All right, I forget about that. I need to actually add that to my Zhush. It doesn't source my profile at this point. Now we can. All right, and you can see that we have Go installed. And so we can do some Go stuff. We also have Rust installed. So anytime I run Rust, I can do it from here, and I have all my Rust projects here. Well, not all my Rust projects, but some of my Rust projects in here. And this is my Linux on Windows. All right, so let's explore this just really quickly a little bit more. Okay, so when you're wanting to configure WSL, okay, so I have a couple things that I wanted to point out that you might just not realize right off the bat. Generally, when you shut this down, so when I get out of this, so let's open up a command line. All right, so I don't have any WSL running. Normally, if I was to run something like WSL-L-V, you would see all of these stopped. But check it out, they're not stopped. Why are they not stopping? Now, first, you should give it a little bit of time. I'll fast forward. I'll cut this out, but I'll give it a little bit of time. Okay, it's been a couple of minutes now. And we'll run it again, and we'll see that they're still running. And you'll notice that 15.2 is stopped. And the reason of that is this right here. So if you want to look at this, my default install is Ubuntu, and I have enable integration with WSL, enable integration with my default WSL. So that's Ubuntu. And then I have OpenSUSE Leap 15.1, OpenSUSE Leap 15.1. And then I have Ubuntu 2024, and there's Ubuntu 2024, and then there's Docker Desktop Data. So, and Docker Desktop. I don't know why it needs two. Don't ask me. This is Docker. Go ask the Docker team. So what we can see here very clearly is that with this integration, it's actually going to keep them running. So why this matters is sometimes I like to restart my my running user space. And I used to do that just by very simply closing and then opening it again. This is what I would do. But I can't do that because it doesn't restart it now. So what I have gone to, so anyways, I just wanted to point that out because the WSL integration is what gives you this nice Docker where I can access it. So if you want to actually shut them down, you need to come over to a command line like this and do Docker WSL shutdown. Now be careful with this because anything running in Docker will also die at that point because it kills your WSL kernel. And like I said, everything is running on that kernel. All the containers are. And so all of your containers go away. So just be careful. But if you're running with the integration and you want to restart your containers, this is how. Once you run this, you're going to get a prompt that Docker says, let me cut. All right. You are going to get this right here. It says Docker desktop, the backend has stopped unexpectedly. Do you want to restart it? You want to hit restart. And that's actually going to bring up Docker and it's going to be starting up. And you can see it restarted all of these because those have the Docker integration. And Docker is running. So we can run Docker PS again. Oh, you can see that our VM got shut down. But everything's back up and going. All right. So the very last thing is to have like all this. I know I have a very pretty terminal. I'm very proud of my pretty terminal. If you want to install fonts or configure this, there are some quirks because the font being used here is actually the font that's installed in Windows. So you have to install the font on Windows. You have to come in here and go to settings. And here in settings, you can configure stuff like the font that you want. I like the Nerd font. So you can go download the fonts from Nerd font and they've patched a bunch of fonts with these pretty symbols. And this is how you can configure how this terminal looks. And if you don't, this is the Windows Terminal app. It's a fantastic terminal for Windows. Absolutely get it. If you're not using it, you are hurting yourself. So go get this app. And and so this gives me this right here. Allows me to configure it and make it a little bit more like a natural Linux.
All right, everyone, that's going to be it for me today. Really want to thank you for joining me as I discuss this. This video has changed like 3 times now. I hope that this was a video that you guys wanted to see. If not, let me know in the comments below what you do want to see. I know, Kubeflow pipelines, full example. I'm working on it. Those are really big and hard to make, and I have to make them in my extra time. So they're coming. Hold your horses or your goats or whatever animal you might have. Hold it. If you didn't like this video, go ahead and hit the subscribe button, stick around, and see if these videos get any better for science.